All right, so we are moving on to lesson 5.1, which is the start of unit 5. This is a very short unit. We were just working on trigonometry for this one, so we're going to be mainly focusing on triangles and then some trig ratios, which has to do with triangles as well. So the first thing we're starting off with is similar triangles. So the first thing that we are going to be doing is we are going to be taking a look at two different triangles that we're going to draw. The first one I'm going to draw is going to be labeled ABC. Let's drop down here. That. So this is triangle ABC. Now we are going to draw a triangle surrounding it, which is triangle PQR, so that P and Q are parallel to A and B, P and R are parallel to A and C, and Q and R are parallel to B and C. So when we do this, what I'm going to end up doing is I'm making a line parallel to A and C to make it easier. Awesome. So P and Q are parallel to A and B. E and R are parallel to A and C, and Q and R are parallel to B and C. Now what we're going to do is use a protractor to measure the angle in A, B, and C and label them on the triangle, then measure the angles in P, Q, and R. So for here, I've got my handy dandy little triangle that I've added. So to start off with, I'm going to measure angle R, which in this case I can see is about, make sure everything's lined up. Five, 3, 6, 7. It is about 38 degrees. If I measure this one, it is a 90-degree angle. If I measure this one here, it is about 51, 2. Now, if I measure A and B, this one is also 90 degrees. This one is also roughly 38 degrees. That's not the best drawn triangle I've ever done, so it might be a little bit off. Oops. And this one is roughly about 53 degrees. So it's roughly 52. Again, that is just drawing error because it's not a perfect triangle, but we will go with it. So the conclusion that we can find when we look at those two triangles is that they have equal angle measurements. So this is what we would call a similar triangle. As you can see, P, Q, and R just looks like a blown up version of A, B, and C. So now if we use a ruler to measure the length on each side of the triangles, what might we get? So if I take a look at them, I'm just going to count squares because I don't have a ruler with me. But if I look here, I have 1, 2, 3. So if I take a look at the length of A to B, I have 3. If I take a look at PQ, I have 1, 2, 3, 4, 5, 6, 7, 8. If I take a look at PR, I have, ooh, that one's gonna be hard. That one I might need to actually measure for. So I'm just gonna have to hunt it down. Oh, there's a hidden ruler. So all I'm doing is just holding a ruler up to the side of them. All right, so what I've done right now is I've just blown up my screen so each square represents a centimeter based on the actual ruler that I have. And this way I can just measure this one line because I cannot count the squares. If I take a look at this one though, P and R is about 13.5 centimeters. And A and C is about 5.5. If I take a look at Q and R, this 10 and this is 4. So if I just type those numbers in, or not type them in, but write them down here, I know that PQ was 8, AB was 3, PR was 13.5, AC was 5.5, QR was 10, and BC was 4. So now if I just divide those numbers, so I have 8 divided by 3, that's going to give me roughly 2.7. 13.5 divided by 5.5. It's going to give me roughly 2.5. And QR 10 divided by 4 is giving me about 2.5. So we can see that these have very similar scale factors. They should be identical. But hand-drawn triangles aren't perfect. Okay, so now if we summarize what we kind of just discovered there, corresponding angles are always going to be equal to one another in similar triangles. And lengths of corresponding sides are always going to be proportional. So if you know angle A on one triangle, you know angle A on another triangle. If you know how much bigger one side is on one triangle, you know how much bigger all sides are. So when we look at it here, angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Line AB, which gives us the small line C, divided by PQ is going to give us the same factor as A to C and P to R, B to C and Q to R. So if we take a look at that, I have angle A right here. I want to figure out which angle it is equal to. In this case, it is going to be very similar, if not the same, as E. Because this triangle is essentially just flipped. C and D are equal to each other, and if you remember from grade 9, that would be the opposite angle theorem, so that also makes sense. So B and F must also be equal to each other. That means that if A and B are one side, and they're divided by E and F, so this length here and this length here, that is going to give us the same ratio as A to C, which is going to give us the same ratio as right here, D to E. In a very similar fashion, I'm just going to erase that before this gets confusing. D and F being similar to B and C, or having the same ratio as B and giving us a ratio when divided by B and C, means that A and B and F and E are going to have the same exact ratio as those two because both of these are similar triangles. So now if we take a look at these two triangles using actual numbers, we want to determine if the following pairs of triangles are the same. So what we can do is we can take a look at, you can see Q and A. We're going to kind of flip this so that P and Q should equal B and A, or should be the same side. A and C should be the same as Q and R, and P and R should be the same as C and B. So if we take a look at that, CB divided by PR should equal BA divided by PQ, which should equal CA divided by QR, if they are the same triangle, or if they are similar triangles. So that means I have 15 over 7 is equal to 8 over 4, which is equal to 10 over 5. This is going to be roughly 2.14. This is 2 though, because 8 divided by 4 is 2. And this is 2, so these two are equal, but this one is not, so they are not similar triangles. Awesome. So now given that A, B, and C are the same triangle as D, E, and F, find the measurements of D, E, and F. So I know that all angles must be the same. So angle F is going to be equal to angle C. Therefore, it is 70 degrees, which we got right here. Angle B, or sorry, angle E is what I'm looking for, is equal to angle B, which is 85 degrees. Now the only one left is angle A. Easy way to find this one, remember back from grade 9, the internal sum is equal to 180. So A is equal to 180 minus 85 minus 70, which is going to give us 25 degrees. So angle D is equal to angle A, which is equal to 25 degrees. Now we have to find the lengths of sides A and F. To do this, we are going to look at our ratios. I know again that A and B is going to be equal to D and E. A and C is going to be similar to D and F. And B and C is going to be similar to E and F. So if I take a look at that, AB divided by DE is going to be equal to BC over EF, which is going to be equal to AC over EF. If I plug in the information that I have, AB is 15 over, we don't know D and E, so we're just going to substitute that with F. That is equal to BC which is A, over EF, which is 2.7. And that is equal to AC, which is 20, over DF, which is 6. So we know all of these have to be equal to each other. When we are trying to do this, we can use what is called cross multiplication. So essentially, what I'm going to use is the fact that I know AC over DF. And if I write that out again, I will get A over 2.7 is equal to 20 over 6. When I cross multiply, I'm multiplying 2.7 and A by 6. So if I do that, I'm going to multiply like this, and I will get A6 is equal to 2.7 times 20. So I'm just going to write this as 6A. So 6A is equal 20 times 2.7. It's going to give us 54. Divide both sides by 6 so that I get A on its own. So that means A is 9. That does kind of look like 9 equals 9, so I'm just going to write that out again. There we go. If I do the same thing with 15 over F is equal to 20 over 6, I again can cross multiply. And in this case, I'm going to get 15 times 6 is equal to 20F. Fifteen times 6 is 90 is equal to 20F. If I divide both sides by 20, I will get F is equal to 4.5. Therefore, side A equals 9, and side F equals 4.5. Awesome. So now if we just take a look at applying these different properties, and this is the last one of our lesson. So a man 6 feet tall casts a shadow that is 11 feet long. A building casts a shadow 139 feet long. What is the height of the building? One thing that you can keep in mind is that you can draw a diagram. I find diagrams are about the only way I can work through these. So that is not a problem, and that is what we're going to do. Here, I have the sun. We'll give him some sunglasses because he's cool. Now, this is where we will learn my drawing sucks. Don't judge. Say I have a man standing right here, woman, person, whoever it might be. They are 6 feet tall. Their shadow goes 11 feet. What I'm essentially doing here is making a triangle where this is a 90-degree angle. This is 6 feet. This is 11 feet. Now, at the same point, I have a building. I don't know how tall it is. I know that its shadow is 139 feet. How tall is it? What I do know is that if these are similar triangles, that means that this length and this length are going to be proportional to this length and this length. So if I take a look at that, I know that 139 divided by 11 is going to be equal to h divided by 6. I can do cross multiplication again to figure this out, which will give me 139 times 6 is equal to 11h. 139 times 6 is 834, which is equal to 11h. Divide both sides by 11. And this will give me about 75.82 feet is equal to h. Therefore, the building is roughly 75.82 feet tall. Awesome. And that is everything for this lesson.